Hey guys, today we're going to be doing a video on the basics of TIG welding, or GTAW. If you haven't already checked it out, I did another video on the theory behind TIG welding. So this video kind of goes along with that to actually show you the basics of welding with that theory as a background, just to kind of solidify the concepts that are behind TIG welding. So this is just going to be a basic video on getting started with TIG welding, getting the weld pool started, start pushing that weld pool across the material, adding filler metal, and then we'll get into three of the basic joints. We'll get into a T-joint, a lap joint, and a corner joint to get started. So hopefully this video is going to be helpful for you, so let's go ahead and get started. Alright, so I'm going to go over the settings on the machine first of all. This is a little older machine. It's a Miller Synchrowave 351. And so this might be a little larger than the machine that you're going to use, higher amperage. It may or may not have the same controls. A lot of the newer machines are going to have buttons for all the different controls, and won't actually have a manual switch for the polarity and stuff like that. So everything might be a little bit different, but I'm going to go over the basics of what polarity we're going to use today, which would be DCEN, or direct current electrode negative, how that's hooked up on this machine, and how we're also set up in terms of all the settings up here and the amperage control and stuff like that. Okay? All right, so we're going to go over the settings up here on the machine. This is a constant current power source, so that means that this will do both GTAW and SMAW. So we need to select the process here. Of course, we're using GTAW, also known as TIG welding today. And then this is our amperage control. So this is whether we want our amperage control to be on the panel itself and keep that amperage, or we want what's called a remote amperage control or a pedal amperage control. So we're going to be using a remote amperage control with the pedal today so that we have some amperage control as we're welding. This controls whether that output is set to just fully on, or if it's set to the remote. So we have both of these set on remote today. This is for our high frequency, whether we want the high frequency to be off, whether we want it to only have high frequency at the start to establish the arc, or we want high frequency continuous. So this is a little bit different from some of the inverter machines that you'll see today. These older machines, you actually have to set this high frequency on your own. And basically we want high frequency start for welding on steel and stainless steel. That just pulses that high frequency at the beginning when we initiate the arc, and then turns it off. And the high frequency continuous would be if we're AC TIG welding, and that will have that high frequency pulsing continuously to keep that arc nice and stable on both sides of the sine wave. If you don't know what I'm talking about with that, we'll get more into that when we do a video on AC TIG welding. But basically all you need to know is that we need high frequency start for steel and stainless steel, and we need high frequency continuous for AC welding. On a brand new inverter machine, you won't set that at all. Then we have our amperage control over here. So this will just adjust our amperage up and down. I just don't have the machine on because it's pretty loud. So for the sound quality, I'm not turning it on right now. Down here, we have our polarity selection. So we have three different options. We have AC, electrode positive, and electrode negative. Okay, so electrode positive would be for stick welding or MIG welding, which we don't have that option on this machine. So this machine, the only options we really have are for stick welding, electrode positive, or AC welding for stick welding, or TIG welding. But today we're going to be using electrode negative for steel. Basically, we want to use electrode negative for TIG welding on steel or stainless steel. Then if we're welding on aluminum or magnesium, we'd want to use AC for GTAW. Okay, so we have the selector pointing towards electrode negative. I'm going to take you down to the bottom. All right, so down here we have where these are actually connected to the machine, meaning the torch and the ground clamp. as well as some other connections that we have down here, such as our gas and our water cooling system, or our coolant system. So on this side, if we look at the schematic here, we have our work lead goes on this side. So we have our ground clamp connected to that terminal. On this side, we have our electrodes. So the our power going to the torch is connected here, as well as our gas is connected on this side, and our water line, which also goes into the torch. So we're using a water-cooled torch system. It's a size 20 torch, and so it has a coolant that will circulate through the torch itself to keep it cool. A lot of machines that you may purchase will not have a cooler on them, so that would be a air or gas cooled setup. So you may not have that on here, but I added an aftermarket type cooling box on mine. So I had to put this adapter on it to get it to where it would flow through the torch. So that's why it might have some extra leads. But basically I just wanted to show you, make sure that you're connected to the right terminal so that when you switch over the polarity, the machine will have the right polarity selected. In addition to that, this machine, because it's older, it has this high frequency intensity that you may need to adjust. So basically you just want enough intensity to where you have a nice crisp arc start. You don't want to turn that all the way up, because then you will burn out those contactors faster, and you'll need to do some maintenance on your machine. Okay, so I've already played with this and gotten it dialed in to where I get a nice crisp arc start, and without putting any undue wear on the machine. Okay, so that's the basic setup. I also have my connector for my pedal here as well, my remote amperage control. All right, let's get started. All right, so I'm going to show you how I put the torch together first, and just the overall setup, because there are some differences that you can use. I'm going to be using a gas lens setup today, which has a screen in it like this. This is the gas diffuser that I'm going to be using. The other type is what's called a collet body. If you look at the video that I did on theory, it'll show you that the other type that you can use. And the collet body is just as good in terms of, it'll do the job, but the gas coverage isn't as good as a gas lens. And it's a little less expensive as well, collet body versus a gas lens. So in order to have the best appearance to my weld and the best shielding, I'm going to use a gas lens today. So that's the first thing that I'm going to put in my torch. This is a size 20, a WP20 torch. So I'm going to screw down my gas lens till it's snug with the head there, so that there's no gap in there to let any air in as we're welding. Then I'm using a size 8 ceramic cup. The number is just the dimension of the opening here in 1/16 of an inch. Okay, so this is a size 8. A little bit larger cup. You could probably get away with a size 7 or even a size 6 or something like that, which would be a little smaller opening, but I like the larger opening, again, to just get a little better shielding, to give a better appearance for our Instagram quality welds that we're going for, right? So that's why I'm using a size 8 with the gas lens. I could get kind of ridiculous and use like a size 10 or a size 12 or something like that, but I don't really need that for carbon steel. I can get some pretty good looking welds just with gas lens and a size 8, so that's what we're going to be doing, okay? So I'm going to, now I have my collet is what this is called, and this is what actually cinches down onto the tungsten itself to both transfer the current to the tungsten, but also clamps down onto it to establish how much of a stick out that we have, okay? So as this back cap clamps down onto, screws down onto the torch, it puts pressure on the back of that collet and will hold it in place. So I do one of two things. If I have my machine off, I can set my tungsten on the material to get, you know, the distance that I want, the amount of stick out that I want, which would be about 1.5 times the diameter of the tungsten itself, something like that. You can go a little bit longer than that with a gas lens, which is one of the things that I like. Or if your machine is off, you can also use your finger to hold that stick out and then just finish tightening that down so that you know, this tungsten won't move around. Now, if you get it all tightened down and the tungsten is still sliding around in there, that typically means that you have that collet body backwards, which is really common. I'm sorry, not collet body, collet backwards, okay? So my joke about the collet is, you know, a lot of students will come to me and they'll be like, you know, that thingy that, you know, you put on the tungsten, okay, that's not what you call it. It's called collet. So if you don't know what to call it, it's probably called a collet. Get it? All right, so that's my collet joke. Anyway, hopefully that helps you remember what it's called though, right? So anyway, that's the setup for the torch. And now we're just gonna go over some basics of the technique, as such as angles and stuff like that, okay? Before I get to that though, I wanted to talk a little bit about arc ignition, how we do it. So there's different options with TIG welding. A lot of these machines, you know, if you've just bought a machine and you're just getting started, a lot of times it won't actually have high frequency. If you bought, you know, a hobbyist type machine that does TIG welding, a lot of times the arc ignition will not use high frequency. So in that case, we would use what's called lift arc or scratch start. Okay, that's where you don't have a foot pedal to initiate the arc, and basically all you do to initiate the arc, you have a current that's set to on. So that would be like on the machine I showed you earlier, the output said either remote or on. You just set that output to on, and then you'd actually touch the material and lift up to start the arc, but then you have no amperage control. Whatever you have set on the machine for your amperage control, it's going to go to that full amperage until you get to the end of the weld, and then you just lift up really quickly. The machine senses that that increase in the resistance, and the arc will terminate. Okay, so that's lift arc, or some of the machines have a scratch start. Okay. So that would be with the output set to on. The other option, which gives you more control and is typical of shop welding in a controlled environment like this, is the remote amperage control, or the foot pedal. So I'll show you what that looks like. Okay, so this is a remote amperage control. It is that box with a little arrow in it. That's the sign that is typically on your machine, although sometimes they'll have a little picture of a foot pedal. So this is a remote amperage control. To initiate the arc, we press down with our foot. That will establish the arc at a low amperage, and then as we go down to full pedal, all the way down, then that will be whatever we have set as our peak amperage on the machine itself. So that's the nice thing about this, that we can start off nice and hot to get that weld pool started, and then we have some control based on what we're seeing in the weld pool of our amperage. Okay, so that's a remote amperage control, and that's what I'm going to be using today. All right, so I have my amperage right now. I have it set at about 125 amps, and that will give me a nice hot start. I can go to full pedal at the beginning of my weld to get the weld pool started quickly. You know, on the different joints that we have, it will vary based on, you know, whether I need to go to full pedal or just half pedal or something like that. But around 125 amps is where I'll be. Especially on the T joints, which take a little bit more heat. But I'm going to start out just by doing some welds on a flat plate. I'm going to show you how to just establish the arc first, establish the weld pool, and how to push that across the material. All right, so let's talk a little bit about angles now. Okay, so for angles, one of the most important things that we see for TIG welding, or that we need to keep in mind, is our travel angle. Okay, so our travel angle is in relation to the direction of travel. So we're always going to use a push angle for TIG welding. So if we're traveling from this location to this location, we want to make sure that we're using a slight push angle, about 20 degrees or so off of 90. So this would be approximately 90 degrees. We want to make sure that we're angled back about 20 degrees, and we want to keep that as we move all the way through the weld, okay? So the mistake that we don't want to make is starting off at a nice 20-degree push angle and then starting to turn that torch as we get towards the end, which is very, very common. Okay, so we want to really lock in that nice push angle and keep that throughout the whole weld. Okay. Another thing that we want to watch, maybe a little pointer here, is the distance between the end of the tungsten and our weld pool. We want to make sure we're not too far away. If we're too far away here, then our arc gets really wide and it starts to kind of wander a little bit, and that will cause all kinds of problems. We want to get real nice and close so that we have control over that arc, and that arc is pinpointing exactly where we want it to be, right? It's a very precise process, so we want to be able to make sure that we're nice and close. All right, the other angle that we have is our work angle, okay, is our angle this way in relation to the workpiece itself. So for just in a flat position like this on plate, we want our work angle to be 90 degrees, okay? We don't want to go off to either side, because then we're going to push that arc off to one side or the other. We want to be straight up and down and a slight push angle to be able to get a nice consistent bead all the way across, okay? So I'm just going to show you now how to initiate the arc, how to get the weld pool started. We just want to press that pedal down until we see that weld pool get to approximately the size that we want it. In this case, that'll probably be about like 3/16 of an inch or something like that. Once that weld pool gets to the size that I want, I'm just going to start to push that across the surface of the plate. I'm not going to use filler metal to begin with, because I want you, especially if it's your first time TIG welding, I just want you to get used to the torch in your hand. You see how I'm holding it? I'm holding it almost like a pencil. I like to hold it like this, especially in this flat position, because then I have control to move it, and then I also have control to change the angle just by twisting my fingers a little bit or twisting my hand to control that angle as I move through. And I can rest my palm or my wrist on the table itself to be able to control that distance or arc spacing as I go through the weld. Okay, so I'm just going to show you how to establish that weld pool and how to push it across the plate to start off with. All right, so here we go. We're going to get the arc started here. Once the arc gets initiated, we're going to push the pedal down until the weld pool gets to the size that we want it. Once the weld pool gets to the size that we want it, then we're going to start to push it across the plate. And we just want to make sure that our travel angle stays the same as we move through the plate, and that our arc spacing stays the same. And we're not getting too far away from the plate, and then we're not changing that angle as we move. Just take a nice consistent speed. Then as we get to the end of the weld here, we're going to let off the pedal slowly to reduce the amount of a crater that we'll get, or a pinhole in the crater of the weld. And also hold our post flow there until the weld fully cools and the post flow goes off, so that we don't end up with any discoloration or contamination at the end of the weld. All right, so now we're going to do the same thing with filler metal. We're going to establish that weld pool first, and then we're going to add the filler metal to the weld pool. One thing we want to make sure is that we're not using the arc to melt the filler metal on top of the plate. That isn't TIG welding. Okay, that's just kind of melting some cold metal on top of base material. Okay, so we want to make sure that we get that weld pool established with the torch first, with the tungsten electrode. And then we add the filler metal to that weld pool. The weld pool is what mounts the filler metal. Okay, so I'm going to go ahead and get started. Going to get that weld pool started and then start to get finished. All right, here we go. So we're going to depress the foot pedal until that weld pool gets to the size that we want it again. And then we'll start to add the filler metal to the weld pool. So we're just dipping that in at the beginning of the weld pool there, at the front of the weld pool. Nice even dipping. And we're just going to continue to push this weld pool across with a nice dip, then move pattern there. And try to keep those angles the same. Try to keep that travel angle consistent. We have a nice gradual angle of the filler metal coming in, which gives us about a 45-degree angle between the electrode angle and the filler metal. So we get to the end of the weld here, we're going to back off slowly and then hold our post flow there until it goes off. All right, so the first joint that we're going to weld is a T joint on 10 gauge material. All the joints that we're going to be welding today are on 10 gauge material. This is a thicker material. It's close to 1/8 of an inch. It's a little bit thicker, which is going to give you a little bit more leeway in terms of not melting through the material or burning it away. So especially if you're beginning, this is a good thickness to start with. So 10 gauge material. Carbon steel, of course. I'm going to be using 125 amps. I'm going to be using 3/32 filler material. It's always different, the results that you're going to get with different diameters of filler. So I could use 1/16. It's going to melt easier and go into the weld pool more smoothly. But I tend to get a more concave weld bead, so I like 3/32 with this thickness. And it also depends, of course, on the size of the weld that you're trying to get. But today I'm going to use 3/32 on this joint. Because it's a T joint, we need a little bit more filler to fill up that area, just on the type of the joint that it is. So that's another reason why I'm using 3/32. This is ER70S-2 filler metal, which is just a carbon steel filler metal and pretty common in industry. Okay, so that's our setup on amperage and filler metal and all that kind of stuff, the type base material that we're going to use. One thing that I wanted to mention is the prep on our material, that wherever we're going to be welding with TIG welding, that we have removed any mill scale, any rust, anything like that, contamination from the material. Okay, so make sure that you're prepping your material with TIG welding. Alrighty, so we're going to go ahead and get started. I'm going to go ahead and tack this material together. One thing that I wanted to talk about with tacking is just the basic technique. I like to set my, whatever I'm going to be welding at. In this case is 125 amps. You can even set it a little bit higher for tacking, maybe 5 or 10 amps higher if you'd like. Sometimes it makes it a little bit easier because you're on cold material. And all I do is where I'm going to tack, which in this case I'm going to tack on the ends here so that it doesn't get in the way of my weld. I'm just going to touch the material, lift up, and then I'm going to go down on my pedal and initiate that arc. And once the high frequency kind of settles down, it'll start a buzz and the arc will flutter around a little bit. But once the arc is established, then I go to full pedal really quick. And that just creates some capillary action as that current increases really quickly. It creates capillary action on both sides of the joint here, on both of the members, that will cause those two to melt together quickly. And that way you aren't sitting there and putting a lot of heat input into your part before you even start welding. So just quickly up to full pedal and then off. And usually if you're pointing right to the area that you want to tack together, you won't have any issues with tacking, as long as there isn't a big gap there, something like that. So these are nice and close together. If I point right to the intersection of those two, I'll get a good tack fairly quickly. Okay? All right, so let's get started tacking and welding this T joint in the 2F position. All right, here we go. So we're going to get the weld pool started again on the material with a 45-degree work angle.
So get that weld pool started right in the corner there, and then we start to add the filler metal to the weld pool itself. Nice even pace, making sure that I'm pushing enough of the filler metal in on each dip to get a good profile. And it's really important to keep this travel angle the same as I move through. So we don't want to start to pivot our wrist as we go through and end up with a push angle. If you do that, you're going to start to see the tip of your filler metal ball up as you bring it in. So if you start to see that, you know immediately, okay, I need to straighten out that angle a little bit, my travel angle, and you'll immediately start to see that balling go away on your filler metal. So as we progress through the joint here, just try to keep our arc spacing the same, our travel angle the same, and keep a nice even pace as we get to the end of the weld here. And then as we get to the end of the weld, we're going to add a little bit more filler metal, let off of our pedal slowly to reduce the amount of a crater that we get. And then make sure that we hold our post flow both on the weld itself and the end of the filler metal so that we don't get any type of contamination.
All right, so now that we've done the T-joint, now we're going to do the lap joint. So that's where we have two pieces that are actually lapped over each other, like so. Okay, so we want to make sure that we've prepped our material, that we've got it ground down to bright shiny metal wherever we're going to be welding. And then I'm going to tack it on the ends here and here, and then I'm also going to tack it on the back side here and here just to keep it from, as I weld it, the distortion of the material pulling up, the shrinkage of the weld pulling it up so that it's uneven. Okay, so I'm going to tack those two together and we're going to get started. Okay, the only difference with this versus the T-joint in terms of our angles is that I tend to use a little bit more of a, instead of like a 45-degree angle on my piece, I tend to bring my angle up about 10 degrees higher so that I don't direct too much of the heat towards this top edge. I either want a nice rolled edge if I'm using enough filler metal or my weld is large enough, my weld size is large enough to roll over this edge, or I want the weld to be consistent to where I'm not getting undercut on that top edge. Or something like that. So I just want to make sure that I'm not, using a typical T-joint 45-degree angle because I will typically burn away that top edge of my lap joint. Okay, so let's go ahead and get started with the lap joint. Also on 10 gauge material at 125 amps with 3 30-second filler metal.
All right, so here we go with the lap joint. We're still using a 20-degree push angle. And like I said previously, I'm going to bring up my work angle a little bit to about 60 degrees or so. Get that weld pool started and start dipping in my filler metal. Now my distance from the edge there is important because as I dip my filler metal in, I just want that top edge of my weld pool to lap over the top edge. We're using 10 gauge base material with a 3 30-second filler metal. So that gives me a weld size that should lap over the top corner of that base material. So I'm just kind of watching the edge of my weld pool as I dip the filler metal in, and I should see it consistently consume that top edge to give me a nice rolled edge to my bead and just give me an overall pleasant appearance to the weld. So as I go through this joint here, I want to keep those angles consistent, and I can start to back off of my pedal a little bit if it starts to get a little hot towards the end here. And then as I get to the very end of the joint, I add a little bit more filler metal, let off of the pedal slowly to reduce the amount of crater that I get. And that completes the joint with holding my post flow over the weld and the filler metal to avoid contamination.
All right, so now we're going to do our corner joint. And with this, we're also using 10 gauge material, but we're only set at 80 amps on our remote amperage control, and we're going to use a smaller diameter filler at 1/16 of an inch. And the reason is because the way that I fit this up, we have a nice little weld prep, which is actually corner to corner. So if we look at this, we can see that the inside corner of both of these plates are actually mated up to where we have the outside corner of those plates sticking up and gives us a nice little weld prep that will melt and sort of round off this whole weld if we do it right. So we don't need a lot of filler in order to fill this small area in the center, and we don't need a lot of amperage. If we use too much amperage, then it starts to really melt away these edges and we get sort of a rough undercut look to the edge of this joint. So if we do it right, it should be nice and rounded and smooth. Okay, so that's my settings and what I'll be using in terms of filler metal for the corner joint. Now it can be a little tricky to get this fit up perfectly, and we don't want any gaps in there or anything. So I've gotten pretty good at just being able to hold those two corners together and then tack it autogenously. But you know, that may be a little bit harder for you. You can use the edge of the table as a guide to hold both of them and tack it, or you can also use an angle, a 90-degree angle fit up magnet, which is really helpful as well. Okay. All right, let's go ahead and get started.
All right, here we go. So I'm going to get the arc started. I'm going to depress the pedal until I consume both edges of the corner joint. And this is important not to get too overzealous with the amperage to where it starts to really consume, you know, both sides of the corner joint and kind of get away from us and get out of control. So I just want to use enough amperage to where it's consuming both sides. And when I dip my filler metal in, I have a nice fluid weld pool that laps over both edges, but doesn't really get out of control. So I'm using a 20-degree push angle or travel angle like I have on the other joints, and a 90-degree angle basically straight up and down on the electrode itself, so that you know, I'm not pushing the weld pool off to one side or the other and ending up with an irregular weld bead. And we just continue that all the way to the end, trying to keep that all consistent. And then again, let off of our pedal slowly to reduce the amount of crater and hold our post flow there as well.
All right, so there you have it. We have our T, our lap, and our corner joint in 10 gauge material. So hopefully this is going to be a help to you on getting started with GTAW, and you'll be able to progress from there. All right, we'll see you on the next video.